first of all, we have a parabola. Does this parabola pass the horizontal line test? No. So currently, its inverse will not be a function. The only way that I could make its inverse a function is if I erased part of the parabola. And that's what this question is looking at. It's saying, determine two ways to restrict the domain so that the inverse is a function. So I would have to erase half of the parabola to do that. How do I show the two ways then? Number one, I could erase that half. Don't actually take out an eraser, you don't have an eraser. But if I erase that half, can you see that now the parabola passes the horizontal line test? So how do I erase that half? I restrict the domain to be just x is bigger than or equal to 1. If I'm just looking when x is bigger than or equal to 1, can you see that you would have half the parabola? What's the important point that we're looking at here? We're looking at the vertex, which the x-coordinate is 1. That's where the domain is going to either be the right half or the left half. Can you see that a second way to restrict the domain I could have erased the other half. If I erased the other half, it would pass the horizontal line test. So this question starts by saying, determine two ways to restrict the domain of the original equation so that its inverse is a function. These kind of questions, when you get them on tests or quizzes, they'll always be parabola questions. And with a parabola, you always find the vertex and take either this half or this half. And so you will need to know the x-coordinate of the vertex. Now, if I took this entire function and I switched x and y, this would be the entire inverse, right? Can you see that -1, -1, 3 would become 3, -1. Okay? And if I find other points on this red graph, for example, I could take this point here and this point here. I have 3, 7 and 1, 7. I would now have 3, 4, 6, 7. On my blue graph, I would have 7, 3. -1, 7 and 7. No, this is, oh my goodness. I'm having issues labeling here, aren't I? Because this is at +1, 3. This is at +1, 3, then I would be at 3, 1. And -1, 7 would be 7, -1, 3, 1, 7, 3. This would be the inverse. And if I wanted to find out, okay, I find this question is complicated for students in a lot of ways because it's involved and things are getting broken up. And this question is really 6 questions in one. We need to split the page here. We needed to restrict the domain twice. So that was already two questions. Question 1, restricted once. Question 2, restricted again. Then it asks for an equation each time. So that's another 2 questions they're asking. And to show it graphically for each one, which is another 2 questions. So this is a complicated question, because when you have this question, you have to do 6 things. It's basically 3 things twice, because you have to do it for x is bigger than 1, and you have to do it for x is less than 1. What we need to find is for x is bigger than 1, and I am going to take out my highlighter, or you can use a color coding. I'm going to do this one in yellow, and I'm going to go to my graph and highlight this part in yellow. Then on my inverse, that includes 1, 3, and 3, 7. So on my inverse graph, that is this part of the inverse graph. I have now done the last part. I've used the graph to illustrate. I have to find the equation of that yellow section. How do I find the equation of an inverse? Well, algebraically, and I'm going to do it below here, algebraically, we find an inverse by switching x and y and solving for y. So if I take the original equation and I switch x and y, I would get x equals y minus 1 squared plus 3. I now have to solve for y. So I'm going to first get the y minus 1 squared by itself. And I can get rid of the squared by square rooting. And if I add 1 to both sides, I get y by itself. This is the equation for the complete inverse. It has a plus and a minus. In our question, we have to determine, is this yellow section, which is the restricted domain when x is bigger than 1, is that going to be the plus 1 or the minus 1? How would you determine that? Couple of ways. The minus out front, can you see that that would be a vertical reflection? If I took a square root graph and I did a vertical reflection, can you see that it would now be going down? The part that we highlighted is not going down. So the equation for this one will be y equals positive x minus 3 plus 1. And the second one, which I'm going to take out a different color highlighter, the second one, if we restrict the domain to be x is less than or equal to 1, that is this half of our parabola, including the point -1, 7. So on our inverse, it includes the point 7, -1. And that one does have a vertical reflection of the square root. Its equation will have the negative out in front. So it's a complicated question because it's asking you to do 6 things. Really, 3 things twice. Restrict the domain twice. Find the equation twice. Show it graphically twice. Think on your take-home quiz, I actually give you 2 graphs so you can split your page and do it twice. So if you had 2 graphs, I would draw this half of the parabola and this inverse. This half of the parabola and this inverse. And draw them separately. I color-coded them for this example. So questions for practice on this, circle 10 and 12.